all cells, these cellular factories, are constantly performing thousands of chemical reactions. Some of those reactions are endergonic, some of those reactions are exergonic. The term metabolism is really the sum of all of a creature's chemical reactions. So it's including those ones that require energy and those ones that give off energy. What a metabolic pathway is really kind of linking all these chemical reactions so that we're being as efficient as possible, if you will, getting the most bang for our buck in terms of energy. So sometimes we use energy coupling, or not sometimes, really often, our cells are utilizing energy coupling reactions where we're using several different um, reacting devices, enzymes, if you will, to slowly release energy and convert it so that our conversion rate is very efficient. So I have a picture there of a hybrid vehicle. It runs on both gas and on electricity. And this is a great example of energy coupling. Whenever the car is moving readily on the interstate, it's going to be relying on its fuel. However, when it's sitting at a stoplight or a stop sign, it's going to go to the battery to kind of just keep the engine idling. So, with regard to the chemical facility of our cell, ATP or adenosine triphosphate is the goal for stockpiling so that the cell can do work. So, adenosine triphosphate, it includes adenosine and it includes three phosphate tails. So adenosine is a sugar and a nitrogenous base, and then the phosphates 1, 2, 3 give us the tri. So whenever we metabolize this, whenever the energy stored in these bonds is released, we call that phosphorylation. We're going to hydrolyze this bond, and when that happens, energy is going to be given off and hopefully harnessed to do work by the cell. When that occurs, here we have our ATP. Here we have water, and we're adding water to hydrolyze um, or to phosphorylate the bond. Energy is going to be given off. And then we create a molecule known as ADP, adenosine diphosphate. So in terms of these energy reactions that are exothermic or endothermic, whenever we go from ATP to ADP, that is an exergonic reaction. Whenever we go from ADP back to ATP, that's an endergonic reaction. We have to input energy to make this product. So these two products are really just recyclable. It's a recyclable molecule that is continually built by the cell to do work. All right. So how is the cell using this to do work? Chemical, mechanical, transport. ATP is going to drive all these reactions. And here's a video I should show you at some point, which is showing motor proteins literally walking along the microtubules of the cytoskeleton to carry materials to different places in the cell. All right, so here we have chemical work. We're reacting a particular compound to make a product. Here we're doing transport. We talked about active transport and the transport proteins, and then mechanical work, what we just described with the motor proteins to move. So again, I mentioned that ATP and ADP are very much interconnected. It's like a rechargeable battery. They're constantly going from one form to another with the cell's goals to stockpile as much of this ATP as possible. And just again, a nice illustration of how this reacts and where we need energy to be put in and energy to be given off.